Good morning student friends. In the last lecture we have started unit 2, that is molding processes. In that we have covered green sand molding process, and now today we will see shell molding process. Here mold cavity is in the form of a thin shell. That's why that process is called as a shell molding process, and that shell is made by using a shell sand. Shell sand is nothing but a mixture of silica sand along with thermosetting resin binder, and the proportion is for 100 kg of silica sand we are using 4 to 5 kg of phenol formaldehyde or urea formaldehyde as a thermosetting resin. Casting process, in which the mold is a thin shell of sand held together by thermosetting resin binder as a urea or phenol formaldehyde. In case of green sand molding process, we have seen that the silica sand has been mixed up with binding material and moisture. But in this case, we have to mix silica sand along with thermosetting resin binder named as urea or phenol formaldehyde in the proportion of, for 100 kg of silica sand we have to use 4 to 5 kg of urea or phenol formaldehyde, which is thoroughly mixed. This technique is developed in Germany. It is also known as expandable molding process. Before starting of the syllabus of this subject, we have seen there are two major casting processes or molding processes named as expandable casting process and non-expandable casting process. Expandable casting process means what? For removing of the solidified casting from mold cavity, we have to break the mold. We have to break the mold for removing of the solidified casting, and that casting process is called as expandable casting process. And for non-expandable casting process, while removing the casting from the mold cavity, it is not necessary to break the mold. Means non-expandable casting process is also called as a permanent mold casting process, because the mold is used many times before it is discarded. By using a single mold, we can manufacture 10,000, 15,000 castings by using a permanent mold casting. But for expandable mold casting, each time you have to break the mold. Each time you have to prepare a new mold for carrying out a casting process. This is a shell molding process, is expandable molding process like a green sand molding process. Now this is the first step. Here you can see this blue color hatching line is a metallic pattern which is mounted on one dump box, and this dump box contains the sand plus resin mixture. Now this metallic pattern we have to heat up to 200 to 250 centigrade temperature, because whatever binding material we are using in case of this shell molding process, that is a thermosetting binding material. Thermosetting means against the heat it is going to cured. As and when this thermosetting resin binder along with sand is heated, it is going to cured. Curing means getting required strength. Getting required strength, that is called as a curing. Now in the first step, what is shown? Metallic pattern is heated at around 200 to 250 centigrade temperature, and it is placed above the dump box, and this dump box contains the sand plus resin mixture. Silica sand is mixed with thermosetting resin binder named as phenol or urea formaldehyde, and it is placed in this dump box. This pattern is match plate pattern or cope and drag pattern. We have seen match plate pattern, cope and drag pattern, gated pattern. Likewise, any type of pattern you can use for this shell molding process, but it must be made up of metal, because we have to heat it above 200 to 250 centigrade temperature. A match plate or cope and drag metal pattern is heated and it is placed over a box. This is the dump box in which sand is mixed with a thermosetting resin binder. This is the first step. In the second step, we have to carry out inversion of the box, so that this sand plus resin mixture will falling on the surface of this heated metallic pattern. In the second step, box is inverted so that sand and thermosetting resin fall onto the hot pattern, causing a layer of mixture to partially cure on the surface to form a hard shell. Now whatever sand plus resin mixture will come in contact with this heated metallic pattern will get cured on the surface of this pattern. It will stick to the surface of pattern and curing is carried out due to the application of heat curing of sand plus resin mixture will takes place. This is the second step, and hard thin shell is formed. In the third step, you can see this red color is a shell. I told you at the start of this lecture that mold cavity is in the form of shell. That's why this process is called as a shell molding process. This blue color hatching line is heated metallic pattern, against of which we have carried out curing of this sand plus resin mixture. Now we have to reposition the flask so that unused sand plus resin mixture will fall on the surface. Inside that box, sand plus resin mixture is falling, which is not came in a contact with the heated metallic pattern. Box is repositioned so that loose particles drop away. This is the third step. Now this shell is our half mold cavity. This shell is our half mold cavity. By the same fashion, we have to prepare another half mold cavity, and they are assembled together to form a thin shell. Now in the fourth step, we have to place that heated pattern along with the shell for curing inside this oven. Sand shell is heated in oven for several minutes to complete the curing. That sand plus resin shell which was sticked on the surface of pattern, that has been removed, and it is placed in the furnace for its curing. And in the step 5, stripping is carried out, means shell mold is stripped from the pattern, and this is our half mold cavity. You can see here the shape. This is half mold cavity. By the same process, we have to prepare another half mold cavity, and they are joined together to form a complete mold. In the step number 6, you can see here the two half mold cavities, they are assembled together in one flask, and that two shells or that mold cavity is supported by using the metal shots. These metal shots is the scrap generated in the foundry industry. That shell is supported in the flask, and clamp is there at the bottom, so that during pouring action of the molten metal, it will not go away from each other. For that purpose, clamping is required, and support to that shell is given. Two halves of the shells or two half mold cavities in the form of shell, they are assembled, supported by sand or metal shots in a box, and pouring is completed. Here you can use metal shots or the granite chips, again any kind of scrap which is present in the foundry industry, or you can use the silica sand also for supporting of that shell. And after supporting of that shell, here pouring is carried out, and after pouring, solidification will take place within 15 to 20 minutes, and we have to break this mold. This shell we have to break down. Again, this shell is taken out from that flask, and this is our area of interest, that is our final casting. Now this is the finished casting with the sprue as well as riser is removed. Now we will see its advantages: the high productivity, low labor cost, and good surface finish. As compared to green sand molding, surface finish is good, labor cost is less, dimensional accuracy is more. As surface finish is good, machining is not required, and this process can be mechanized for the mass production. All these are the advantages. Disadvantage is that you have seen in the figure that we are using metallic pattern for the shell molding process. That's why it is an expensive technique, because we are not using wood, which is possible in case of green sand molding process, and this is difficult to justify for the smaller quantities. Because I am investing more money for the metallic pattern, I must use that process for the mass production. This is advantages and disadvantages of the shell molding. Turbine vanes are made by this shell molding operation. That is one of the application of this shell molding.